my whole projector and everything screwed up. Anyway, I wasted the entire class period trying to figure out how to fix my projector. So, alright, so today we are going to talk about what's called a conditional statement, okay? I will warn you, today is a lot of writing, so just as a reminder, anything that I write on the board, you should write in your notes. So I type out the directions. You don't have to write out the directions, that's fine. But we're going to be doing a lot of writing. Anything that I actually write on the board, you need to write in your notes, okay? Now the first part, there's not really a whole lot of writing to do. I have basically everything typed out for you. So today, like I said, we're talking about conditional statements. A conditional statement, it's an if-then statement. So maybe I could say, if you are in my classroom right now, then you are in advanced geometry. Okay, that would be an example of a conditional statement. Now there's two parts to a conditional statement. There's kind of the first part, the if you're in this classroom. Okay, that's called the hypothesis. Okay, the part that comes after if you are in this classroom. Okay, then what comes after then is called the conclusion. So I can say, if you're in this classroom, the conclusion I can draw from that is that you are in advanced geometry. Now, kind of like when we talked about the statements from yesterday, I could say a statement, and it doesn't necessarily have to be true. If a conditional statement is true, okay, you have to be able to show that every single time the hypothesis is true, the conclusion is also true, okay? Now we are going to learn a bunch of notation today, ton of notation today. It's all pretty similar and pretty simple. But this right here where it says P and then the arrow and then Q, this is the conditional statement notation. How you read this is you say if P, then Q. If P, then Q. You can also say P implies Q, okay? And then we have this diagram here. So if P is kind of, if you want to think of it in a way, a smaller part of the larger, okay? So another example of my conditional statement here would be, if an animal is a chihuahua, then the animal is a dog. So the two parts of this statement, we have the if, an animal is a chihuahua, okay? So that first part, the animal is a chihuahua, okay? That's the hypothesis. The hypothesis. An animal is a chihuahua, okay? Then, what I can conclude from that, the animal is a dog. That second part is going to be the conclusion. Now, like I said, a conditional statement can either be true or false, okay? In order to prove that it's true, you have to be able to say that every single time, in every single instance of the hypothesis, every time that's true, the conclusion is also true. So in this example, every single animal that's a chihuahua, every chihuahua in the entire world is also a dog. That's true. Okay? So that would have a truth value of true. Okay? If a conditional is false, kind of like we talked about yesterday, all you have to do is come up with one example where it doesn't work. Just one. That's all it takes, okay? And in this case, I mean, maybe there's like some weird chihuahua somewhere that's actually a cat. It doesn't happen. That's all it would take. It's just one example, okay? So we have just kind of your basic conditional, the if, then. What we can, let me go back to it. So we've got examples of true and false. So true, okay, if a person lives in Wichita, then the person lives in Kansas. So if it's true that a person lives in Wichita, actually lives, sleeps, right, has a house, whatever, in Wichita, that person always has to live in Kansas, right? Because Wichita is in Kansas, right? You can kind of think about, right, Wichita, Kansas, okay, the bigger circle there, okay? Now an example of one that's false, if a person loves math, then the person is a math teacher. Okay, well think about all the people that love math. Like Sam here, loves math, right? Okay, is he a math teacher? Just takes one example, just Sam, okay? So, examples of true and false, just with one counterexample, okay? Now, another thing that we're going to talk about, all of this lovely notation here, okay? These are different types of statements that we can draw from the conditional statement. So one thing we are going to do when we get down to here is we're going to talk about the negation of a statement, okay? It's just the opposite of the statement, and you use this little squiggly symbol here, okay? And how you say that is you say is not P, okay? We'll get down to that whenever we get down here at the bottom, okay? So the first statement, like we talked about, is just your plain old conditional. Okay, the plain old conditional, how you write it is you just take the hypothesis and the conclusion, you put if before the hypothesis and then before the conclusion. So my example here, if the measure of angle A equals 15, so we've got some angle that measures 15, okay, then angle A is acute, okay. I didn't put this column here because I ran out of room, the graph wouldn't fit on here. But what I want to do is I want to add a little column over here and talk about the truth value. So, if a measure of an angle equals 15, so think about every single angle you could possibly draw that measures 15. Is every single one of those angles going to be acute? Yeah, it'd have to be. So the truth value of that statement would be true. Okay? We talked about the symbols. It's going to be P and then the arrow and then Q. We say it if P then Q. Now the first thing we can do, this is pretty simple. It's called the converse. You're just going to flip it in a way. Okay? You're going to swap the hypothesis and the conclusion. Okay? So like this example, we're going to say if the angle A is acute, then the measure of that angle has to equal 15. Okay, so remember, I'm talking about the truth value here. If this is true, it means that every single acute angle, every time I have an acute angle, it has to measure 15. Is that true? No. Now, if it's not true, you should be able to give me a counterexample. What's a counterexample of an acute angle that does not equal 15? What? 89! You could have a measure of an angle that measures 89, and that's acute, but doesn't equal 15. You can put so many in them, right? Okay? Now this one, the notation, you just swap the Q and the P. So if Q, then P. Okay? So it's pretty straightforward. These are the ones that I really, really have to think about a lot whenever you start negating things. Okay? So next thing we can do is do the inverse. What the inverse is going to do, it's going to negate both the hypothesis and the conclusion of the conditional. So you're going to go back to your original statement, and you're just going to negate the P and negate the Q. So you would go back to this statement and say if measure of angle A is not 15, okay, so I just took that statement and said it's not 15, then the angle of A is not acute. Okay, now these are the ones I really have to kind of take it like step by step and think about the hypothesis, okay? So I have an angle, it does not measure 15. Does not measure 15. So think about all the angles that don't measure 15. Are there any of those that are not acute? Yeah, a bunch of them, right? There's a ton of angles that don't measure 15, actually all of them, right? That are not acute. Like what? 100, right? Any obtuse angle, right? So that would also be false. Now, like I said, the negation symbol is just that little squiggly, and this would be red if not P, then not Q. Okay, then the last one is called the contrapositive, which is kind of a fun word. And it's going to do the same thing as the inverse, but it's going to negate the hypothesis and conclusion of the converse. Okay, so we're going to look at this statement and negate both of them. So we would say if angle A is not acute, then the measure of angle A is not 15. Okay, so once again, I really have to take these in pieces. So let's say we have an angle. It's not an acute angle. Not an acute angle. So think about all the angles that are not acute. It does not measure 15. That'd be true, right? Yeah, if you got it'd have to be an obtuse angle. And an obtuse angle, there's no way it could measure 15. So that would be true. And then the notation here would be if not Q, then not P. Okay? Do a lot of practice with these once we get into the other side of our notes. Questions on any of that? Okay, this needs glued into page 21 of your notebook. This is 2.2, conditional statements. Conditional statements. So the first thing we want to do is we want to look at a conditional statement and identify the hypothesis and the conclusion. So number one, my conditional statement says, if you are an American citizen, if you are an American citizen, then you have the right to vote. If you are an American citizen, then you have the right to vote. So there's two parts of this conditional. There's the first part, and if this first part is true, if the conditional is true, every time that's true, the second part also has to be true. And I didn't say this was a true conditional, by the way, okay? So the first thing, we want to identify the hypothesis. So the hypothesis is going to be the if this is true. Well, what's the hypothesis here? Yep. You are an American citizen. You are an American citizen. Now the conclusion is saying, okay, what I'm stating is that if you are an American citizen, what am I concluding? And you have the right to vote. You have the right to vote. Now, I know it doesn't ask for the truth value, but if I were testing out the truth value, I would have to decide, okay, every single American citizen, does every single American citizen have the right to vote? No, you guys are not 18 yet, right? And I mean, a bunch of other people, like incarcerated people and stuff like that. So yeah, so this would be false. Didn't ask you, but good to talk about those. Okay. Next thing, we want to write each sentence as a conditional. Okay. Now remember, the big thing whenever you're writing a conditional, the big things I should see is I should see the word if, and then your hypothesis, and then the word then, and then your conclusion. Okay. So number 2, my first sentence. Adjacent angles share a side. Adjacent angles share a side. Now, last hour I think this was a little bit harder to think through just because we're new with it. Because it kind of seems just like one thing. Adjacent angles share a side, okay? But there's one thing that has to be true first, okay? Before I even talk about the second thing, okay? What's the first thing that would have to be true? That they'd have to be adjacent angles, okay? That's your hypothesis. So I would say if two angles are adjacent, okay? So if they are adjacent, then what is my sentence telling me? Yeah, then they share a side. Then they share a side. So you kind of have to hunt around just a little bit, pick out the first part. This has to be true before I can even talk about the second part. Okay? If two angles are adjacent, then they share a side. Okay, let's do one more of those. Dolphins are mammals. Dolphins are mammals. So this one really just seems like one thing, right? Dolphins are mammals, that's it, okay? But before I can even tie those two things together, what's the first thing that has to be true before I could even address the second thing? Right, it has to be a dolphin. Right? There's two parts, the dolphin part and the mammal part. So the first thing that has to be true, if an animal is a dolphin, if an animal is a dolphin, then what? kind of touched a little bit on the truth value, whether it's true or not. So now we're going to address these things. If a conditional is false, you have to be able to prove a counterexample. Okay? Just one scenario. That's all it takes. One scenario where it doesn't work. Okay? So number 4, my conditional says if a number is divisible by 3, if a number is divisible by 3, then it is odd. If a number is divisible by 3, then it is odd. Okay, now here's the thing. If this is true, it means that every single time my hypothesis is true. Now my hypothesis is a number is divisible by 3. So think about all the numbers you know that are divisible by 3. If this is true, it means every single one of those numbers is odd. Is that true? Now, if you're saying it's false, you have to provide me with a counterexample. You have to provide me with a number that's divisible by 3 that's not odd. 6. 24. Yeah. 30. Yeah. Yeah. There's so many. I'm actually every other one, right? Okay. All right. Let's do one more of those. Number 5. If 2 angles form a linear pair, if 2 angles form a linear pair, then they are supplementary. If 2 angles form a linear pair, then they are supplementary. And I think it helps to just think of, just the hypothesis first, okay? The hypothesis is 2 angles form a linear pair. Now, we kind of struggled with this idea of linear pairs on our test, okay? A linear pair, I think it's a line broken up into 2 angles. That's all it is. It's 2 angles that side by side form a line. Okay, so think about all the ways you could split up a line into a linear pair. Okay? Are all of these going to be supplementary? What does supplementary mean? Okay, they have to be 180. Well, I know that a linear pair is a line broken into 2, so it's going to be a line. What does a line measure? 180. And if it's a linear pair, it has to be a line. And if it's a line, it has to be 180. Yeah, that's true. It's kind of like, in a way, the definition there. That is true. Okay, last thing, and I think you have a couple of these in your homework. And it's very wordy directions, okay, because there's a bunch of things we're going to do, okay? First of all, I'm going to give you a statement. If it's not in an if-then format, we're going to write it in an if-then format. So write it as a conditional, okay? Then we're going to write the converse, inverse, and contrapositive. And then we're going to decide is each one of those true or false. If it's false, you have to give a counterexample, okay? So the statement we are going to do says pianists are musicians. Pianists are musicians. That's my statement. Okay, now first thing, is this in if-then format? No, I'll see if-then. Okay, so let's talk. This would be a good time to talk about that notation. Okay, so if I want to write just the conditional, that's the P, then Q. So P, an arrow, and then Q. Okay? So I need if, the hypothesis, then the conclusion. Okay, what's the first thing that has to be true? If a person's a pianist. If a person is a pianist, then what can I conclude? They are a musician. person is a pianist, then they are a musician. So if I want to decide if this is true or false, I can decide, is every single pianist, every single person who plays the piano, are they also a musician? That's true. Okay, so we can say the truth value there, okay, is true. Okay, next thing, we want to write the converse, okay? The converse is easy to do. You just flip them, okay? The notation for this is going to say if Q, then P. If Q, then P. And we're just going to take the conclusion, turn it into the hypothesis. So we're going to start and say, if a person is a musician, if a person is a musician, then they are a pianist. Just flip them. If a person is a musician, then they are a pianist. Okay, so remember, if this is true, it means that every single person who is a musician, think of everybody you know that's a musician, are they a pianist? No. Right? Now, there's a bunch of them, but you only have to come up with one. What's an example of one? What? A drummer. Yeah. A drummer is not necessarily a pianist. Okay? The next one we're going to do is called the inverse. Okay, the inverse, you are going to take the original conditional and you're going to negate the hypothesis and the conclusion. Notation-wise, it looks like this. If not P, then not Q. If not P, then not Q. And it's going to read like this. If a person is not a pianist, we're going back to the original one. If a person's not a pianist, then they are not a musician. If a person is not a pianist, then they are not a musician. So once again, I know these are sometimes hard for me to think about. I have to think about it in 2 steps. So I'm going to think about all the people that are not a pianist. I personally do not play the piano. So I'm not a pianist, okay? Does that mean that I'm not a musician? No, right? Maybe I used to kind of play the guitar. Not really, but no, okay. What would be an example? A drummer. Yeah, same as before, right? A drummer is not a pianist, but doesn't mean they're not a musician. They are still a musician. Okay, then the last one is going to be the contrapositive. So it's going to look similar to this, except it's going to say if not Q, then not P. So this one, you are going to take the converse, okay, that second statement we wrote, and you're going to negate the hypothesis and conclusion of the converse. So we would say, if a person is not a musician, if a person is not a musician, then they are not a pianist. If a person is not a musician, then they are not a pianist. Okay, so once again, let's think about all the people that are not musicians. Got any of those in here? I probably should raise my hand on that. I'm not a musician. Okay? Not a musician. Are all the people who are not musicians not pianists? Yeah, because if they were a pianist, they would be a musician, right? So that one is going to be true. Okay, questions on